Good morning. He is my teammate Nicolás Rios Balsells, and I am Natanael Moya. We are electromechanical engineering students, and we are doing the third year at Universidad Tecnológica Nacional, Facultad Regional Paraná. This is a final project of English 2, and the title of the project is Industrial Wastewater Management Efficient. Let me reformulate. The title of the project is Industrial Wastewater Treatment, Efficient Management and Reuse by means of batch recirculation electrocoagulation.
And now we move on with the context or the context description. And I have to say that we separate this context in two parts. First, the society, and then the issue approach or how we approach the topic of this research. First of all, in our current society, the industrial development has been very notorious, but it is related to many environmental and health problems. But also, the truth is that water is our most appreciated resource, and basically, without it, we or any living being cannot longer live. So it is because of that that we have to ensure the availability of this resource. And also, in relation to this issue or this resource, the contamination from the industry sector and also from the urbanized areas is from both places is very notorious, and this has to be there has to be a proposed solution. So, in the other hand, we have the issue approach. In our criteria, we wanted to approach this issue by utilizing or by using as a guidance two of the SDGs proposed in the 2030 agenda, which are SDG number 6, clean water and sanitation, and also number 12, responsible consumption and production. We wanted to approach these two SDGs because our idea is connect the sustainable development with the industrial sector.
Okay, the industrial sector is very important to a country's economy. So the solution that we propose needs to be efficient without compromising this process. So the correct answer is a good wastewater treatment. The best proposal is an innovative technology, in this case, the batch recirculation electrocoagulation, or BRE. From now on, we will start using the acronym BRE. In a few words, the BRE is the best proposal because it only uses electrical energy and the water does need pre or post treatment. So the purpose of the paper is to analyze the common methods which are used today and this new innovative technology. To achieve the same, in the first place, the problem caused by wastewater will be discussed. Secondly, the industrial wastewater characteristics will be described. In the third place, the common wastewater treatment methods will be approached. And finally, an innovative wastewater treatment, in this case, the BRE method, will be rated in terms of viability and efficiency.
Okay, now moving on to the impact that we wanted to discuss in the lecture or in the readers. Basically, we wanted to approach our topic, our issue, and basically to by collecting the information about the different methods and the new technology and comparing it, we wanted to put together this information and may help engineers, students of engineering, or simply other researchers that are looking for the information of this topic, and also encourage them to formulate, to have new ideas to achieve sustainable development in relation with this area of sustainable development. And also the other objective is to help spreading the different information around the researchers community, basically to help other people to do their own investigation and to formulate, like I said, their own ideas about this same topic.
Okay, we will describe in this case the contamination problem. That is the first part of the presentation. There are three main contamination problems related to the wastewater. The first one is the water scarcity. The second is the harmful effects on life. And the last one is the harmful chemicals and components released into the air and soil. In relation to water scarcity, the industrial process generates wastewater that is released in a body of clean water, such as rivers or lake, and this situation makes the water no longer fresh because a small amount of wastewater contaminate large volumes of clean water. In relation to harmful effects on life, the aquatic living beings suffer the consequence, and the pollution make the ecosystem uninhabitable for this kind of living beings.
All right. And for the last, the harmful chemicals into the air and soil. Firstly, we have that the lower level of toxicity in the air only produces bad smell. But if these toxicity levels continue rising, the air may become toxic for any kind of living beings. And then we have the harmful chemicals, or the effect of the harmful chemicals in the soil, that the main, or basically the main problem of the releasing harmful chemicals into the soil is that the plant absorb these toxic components, these toxic chemicals, and basically the plants died, and the soil cannot be used anymore, basically. And now we move on with the second part. Basically, we want to explain the two principles, the two main groups of wastewater characteristics, which are firstly the physical aspects and then the biochemical aspects. Before we explain these two groups, it is important, we wanted to say that it is important to know the characteristic of the contaminated water before it is treated, because in this way we can know the level of contamination, or we can define a certain level of contamination of the water, and then design a suitable solution for treat this water. Well, firstly, with the beginning of the the physical aspect, we have water temperature. Basically, water temperature arises or increases after a production process, and when it's released, the water has a high temperature. The problem with this aspect is the higher the temperature, the greater the harmful effect on the ecosystem. Other physical aspect is the total suspended solids, which acronym is TSS, that basically is a measure of the suspended particles present in a certain body of water. And then we have the total dissolved solids, which acronym is TDS, and it is a measure of the dissolved organic and organic substances in a certain body of water, like before. And well, one of the things in common between TSS and TDS is that both of them can modify the taste, the smell, the color, and the corrosion properties of the wastewater.
Okay, in the other hand, we have the biochemical characteristics that compromise the biological and the chemical characteristics. Uh, uh, sorry, this can these characteristics have sub-characteristics, and the first one is biological oxygen demand, or BOD. BOD is a measure of the quantity of oxygen present in the water that microorganisms use to degrade and mineralize organic matter. Secondly, we have a chemical oxygen demand, or COD. COD is a measure of the quantity of oxygen present in organic matter. And in the other words, COD is used to measure the degree of pollution present in organic matter. And finally, we have the pH, and the pH is a measure of the acidity or alkalinity present in the water. Okay, this is the part 3 of the presentation, and they are the most commonly wastewater treatment used in the world. Basically, there are 3 main wastewater treatment, and the first one is the physical method, which is the most used, which is the most commonly used in the world. They include the absorption process, which use porous materials such as activated carbon to clean the wastewater. Secondly, we have electrolytic method that use anodic oxidation and cathode reduction, and this method use a current to work. And finally, we have the magnetic separation that use a magnetic field to attract heavy metals present in the water. Although this treatment is inefficient, better results can be obtained by adding coagulants. The second group is the chemical methods. These methods are based on the chemical reactions. They include the flocculation method, which is an improvement for the principal for the common physical method, which is precipitation by adding a coagulant. And finally, we have neutralization method, which is which adding a pH value in the water to make the water less toxic.
And for the last, we have the biological method. Between these 3 methods, the biological method is the newest, and in some configurations, it also is low cost. but the main problem with this kind of methods is that they need to be, and it has to be done in a very controlled environment, and the cost generally generally increases the because of the quality in the quality needed in the components to build this kind of drill. And also between the three, we wanted to say that the physical, the chemical, and the biological method can be used simultaneously, like it is shown in the picture, but the results do not justify the high cost of all this treatment plan.
Okay, this is the final part of the presentation. And before explaining the innovative wastewater treatment, which in this case is the BRE method, we need to introduce the foundation of this method, which is electrocoagulation, or EC. From now on, we will start using the acronym EC to refer to electrocoagulation. So there are three implementations of electrocoagulation, which depends of the kind of wastewater that we need to treat. In the first case, we have microplastics, which this kind of wastewater that have microplastics can be treated by using a easy process. In the second place, we have pharmaceutical industry, and this kind of wastewater have certain pollutant that the only way to treat this kind of wastewater is using a electrocoagulation process. And finally, we have textile effluents, and this wastewater is characterized to have chemical and high values of pollutant. So a good option to clean this kind of wastewater is using a electrocoagulation process.
On the other hand, we have the operating parameters of this process, and it is important to explain each one of the operating parameters because they also are the foundation of the innovative treatment that we will present in the next section. So the first one is the initial pH value. It is important to know beforehand the pH value to define if we will need a substance to increase the alkalinity or the acidity that will be present in the wastewater for the treatment. Then we have the treatment time, and the treatment time will vary or will fluctuate depending on the level of success or the level of efficacy that we need in the treatment. Then we have the temperature, which can be modified to increase the efficacy and the efficiency of the treatment. Then there is the current density and energy consumption. It is well known that energy consumption is related to current density, but it is an operating parameter because we can modify the current density to make to accelerate the process, but it will mean it will be translated in more energy consumption. And also for the last we have the electrodes, material shape and spacing. Material shape and spacing is or are the characteristics that can modify and can increase or decrease the efficiency of this water treatment. So in this next section, once we once we have explained the foundation and the operating parameters of this new innovative wastewater treatment, we present the batch recirculation electrocoagulation. Like Natanael said in the beginning of the presentation, we will approach its name as BRE. So basically, the BRE is an effective treatment for industrial effluent, and even though it has been only tested in different kind of textile effluents, it is stated in the other research and with experiments that it can be used in different kind of wastewater. Uh, for example, the distillery effluent. So this method is very simple, and basically what or the difference between this system and the electrocoagulation alone is that the batch recirculation electrocoagulation uses a batch to recirculate the same water over and over again, and with the objective to not use more clean water in the same process or in the same production process.
So I am going to explain the different advantage and disadvantage of the BRE process. Starting with advantage, the first one is cost effectiveness. The BRE process is cost effective because doesn't need the expensive chemicals to work. In the second place, we have efficiency. So the BRE process is efficient because when the process is working, it generates coagulants that catch the solid particles present in the liquid. Also, this process only needs electrical energy to work, and this energy can be provided by a renewable source. Finally, this is a green technology because the BRE process doesn't need the use of chemicals. Uy. Okay. In the other hand, we have the disadvantage of this process. In the first place, the long operating time, depending on the kind of wastewater or the level of toxicity that this wastewater have, the operating time can be longer. In the second place, we have limited applicability because depending on the pollution that the wastewater have, sorry, let me reformulate. The BRE process only can clean certain kinds of pollutant. So there is different types of wastewater that this BRE process cannot be cleaned. And finally, a developing method, because the BRE is a prototype, so needs further investigations or research to become this process a good rival in the current market.
And then we have the viability aspect of BRE. Basically, the two things that we wanted to emphasize in is that this process, this method, need further research, and also related to this, the flow rate and the energy consumption are aspects that can be improved in the near future. Okay, and then finally we have explained this new solution, the methods, and how it affects the ecosystem. And finally, we wanted to approach this final section with our final thoughts about the research. Basically, the resource that we wanted to approach, that is water, is highly important for the stability of a society, and also for a social and sustainable development in the future. The other thoughts we have is that although many researches, projects, investigations, more are being currently elaborated, in our criteria, the most are being elaborated about many resources that are currently used in the planet. We wanted to approach, based on our criteria, the most appreciated resource for the life, that is water. And based on the approach of this research, we thought that the promising nature of VRE is a very promising solution to approach sustainable development by using the foundation of the SDGs. The SDGs that the 2030 Agenda stated from the United Nations, and also it is important to achieve not only number 6 and 12, like we say. It is important to achieve all the SDGs in order to become more sustainable. And therefore, the industrial sector can continue growing without compromising our most appreciated resource, and therefore without compromising the future generation. Thank you so much for your time and for your attention.